Hey guys, welcome back. Today we're in the third part of a series on road corridors, and Casey's going to show us how to create the corridor assembly. So let's learn.
Welcome back everyone, this is Casey. Today we're going to be continuing on our corridor series. So where we last left off, we had just finished completing the vertical alignment for our entrance road here. So just to do a bit of a recap, we have our horizontal alignment for our entrance road, we've got our horizontal alignment for our back road, and our horizontal alignment for our center road, each of which is going to have a corresponding existing profile which we're going to use to create the vertical alignment. So we've created the vertical alignments for all three of these using the same process of taking our spot elevations from our conceptual grading plan, which you can see in plan view here, in these pink spot elevations, and then we translated them onto our existing profile, and then use them as reference points to design our vertical profile, which you can see here, here, and here. And now that we've completed this step, we're ready to create our assembly. So we have a file, CVLX7 Styles and Corridor Assemblies, which has a bunch of assemblies that we've used for corridors in the past. It has some that we haven't made much use of, but can provide good reference points for building your own assembly and for doing some pretty cool things using corridors. So essentially, to explain what an assembly is, it's basically the cross section of the road that you're designing. So if we zoom out to say this guy, for example, as you can see here, we've got a road with two different halves. It's crowned in the middle, so it's higher in the middle, and then it has gutter on each side, as well as a sidewalk on one side, and then it has what's called a daylight, which you can see here in the name. And then the daylight is essentially going to tie in the contours based off of your existing surface. So you can basically build sub-assemblies or assemblies out of a vast array of sub-assemblies, a lot of which are already specified in CAD, and you can see these sub-assemblies by opening up your tool palettes. And when you open these up by default, they're going to be set to all palettes like this, which has a ton of different palettes, a lot of which are pretty much useless for for our purposes. So the first thing you're going to want to do when you open up your tool palettes is, if it says tool palettes, all palettes, you're going to go to the settings icon or the properties icon, and you're going to change from all palettes to civil imperial subassemblies. And this is going to pop up basically all the subassemblies that you'll need, except maybe a handful of subassemblies that you might need to create some sort of custom road if you have something a little bit unique. For example, we have a roll curb for this. And this is going to have a ton of different sub-assemblies that you can use. It has some general assemblies that are basic that you can use to build off of, as well as a ton of different sub-assemblies you can use to build your custom assembly. So essentially what you can do is use the sub-assemblies to create one assembly that's like the way you want your road to be. So say in one instance you might have a required 5-foot wide sidewalk on each side of your road. You can build out your road as normal, and then you can specify your 5-foot sidewalks on either side, custom or unique to the specific requirements of that project. So it's pretty common that we'll build sub-assemblies from scratch or based off of another assembly in order to meet the requirements for the project that you're doing. However, we do have a bunch of assemblies that you can reference located within this file. And as you can see, the reason why there's so many of them is that there can be different demands for a ton of different projects. These ones under this From Crestline box are used to do pretty large swaths of site grading. So you have a road here in the middle with sidewalks on each side, and then it has, essentially it'll grade for you out a basement lot, which will then daylight, after the specified widths of the basement lot and specified slopes and whatnot. So you can do some pretty large corridors that are going to do a lot of your grading for you. However, that gets quite complex, and we'll probably touch on that a little bit more later. So for this project, I've already created this assembly, but we're going to go through the process one more time. So the first thing you're going to do is you're going to want to hit the Assembly drop-down menu, Create Assembly, and then you can name the assembly, and then you can set the assembly style and the assembly layer. We're going to go ahead and set the assembly layer on 0. Press OK, right? And then we can specify where we want our assembly, so we'll click, and then this is going to be essentially the center point of our assembly. And then we can build it out from the center point. So the first thing we're going to do is we're going to select the Lanes tab, and we can select a crown lane or a lane super elevation. So we're going to select this guy, and then it's going to ask you to select your marker point within the assembly. So this is our assembly here, and then the marker point we're going to be building out from the center. So we have this center marker point, which we can select. So go ahead and click. And then it is going to insert our lane, which I'm then going to select and change from left side to right side. And then I'm going to insert one more, which will insert as a left. So now I have one on the left and on the right. And as you can see, when you select these and you look in your properties pane, it's going to come up as a subassembly. And they each have their own specified parameters. So the parameters are going to look different for different types of subassemblies. But for these lane subassemblies, they have a width, a default slope, and then pavement depths. So it's pretty common that we'll have some sort of aggregate base and then asphalt on top of the aggregate base. And there's multiple different pavements, and you can specify those depths, and then it'll essentially grade out all the way down to the bottom depth of the aggregate base or whatever base is being used, right? And so that way, if you generate takeoffs using the proposed surface that is the output from your corridor, it'll be more accurate because it'll take into account the actual depth of the road, rather than assuming that the road is just, has zero depth, and that the top of this pavement surface is where it's graded to. So all of this data can be changed here in the parameters. So for this project, our lanes are going to be, our road is going to be 24 foot back of curb to back of curb, and we're going to have 2 foot roll curb on each side. So we're going to have 2 foot on the left, 2 foot on the right of just curb, which leaves 20 feet to go in the middle. So each lane will be 10 feet wide. Half of 20 is 10. So we can go ahead and change our lane width to 10 feet for each of these. And then the default slope from the center point of the road can remain 2%. That's pretty standard, so we're not going to touch that. And we'll just leave the pavement depths alone for now. And now we're going to specify our roll curb. So the reason that I'm building out this assembly in this file rather than the CD file is because I want to copy some sub-assemblies that are already existing in this file. One of which being this rolled curb subassembly. So copying sub-assemblies from one assembly to another assembly can be a little bit tricky, because if you select this and hit Control-C and then Control-V, nothing's going to populate, nothing's going to happen. The only way that you can copy is by selecting the subassembly, and then in the top left of your corner, assuming you're under the subassembly tab, is this little copy button. So you can go ahead and click that guy. And then it's going to ask you to select a marker point within the assembly that you would like to paste to. So I want to copy this guy on this marker point, so I'll just go ahead and click, and then it's going to paste over, and then this subassembly is now within this assembly and not this guy. So I can do the same thing, this roll curb, click on it, hit copy, and then I can come down here and then copy it right here. Okay, and then these roll curb have completely different parameters than these lanes do. So we can click on the roll curb, and it has a bunch of different dimensions that specify the width and height of the curb at certain points. So I can go ahead and pull up a standard detail for the curb. So this is standard detail for regular or vertical curb within our jurisdiction. So if we wanted to specify regular or vertical curb, we would simply use a different subassembly for regular or vertical curb, and then we could modify the dimensions to match the standard detail for the city. And you can do that all within the parameters tab for each set of curb. So now we have to take into account our right-of-way width. So as of now, we have a 40-foot right-of-way width on our project. So 24 feet of that right-of-way is taken up by the road, which leaves 16 feet to be used for sidewalk or for tying into existing grades. So we're just going to go ahead and assume that we're not going to have a sidewalk. We may have a sidewalk later, in which case we can change the assembly and rerun our corridor. But for now, we're just going to assume that all we have is just a general width. So we're going to select link width and slope, which we can then click, and we're going to go ahead and throw that in on both sides. Okay, and on each side of the road, we're going to want the water draining into the road so that it gets into our gutter and then follows our gutter to our storm system. So we want these guys to be sloped towards the road, which they are by default. If we click on these guys, you can see that they have a certain width and then they have a certain slope. So essentially what this is it's going to be 10 feet at a 2% slope from this point, right? Very simple subassembly. Well, we have a 40-foot right-of-way. 24 feet is accounted for by our road, and if we have 10 feet on each side, that's plus 20 feet, which would be 44 feet. So we're going to shrink these guys down to 8 feet each, leave them at 2% slope, and then we're going to add what's called our daylight. So we're going to go ahead and go to the daylight tab under our tool palettes, and we're just going to select a daylight general, and then we can add that to the ends of our link width and slopes. So I'm going to go ahead and add one to each of these sides, hit enter. Okay, and then typically we'll tie into the existing grade at a 2-to-1 slope, right? That's the steepest it will go. So you can just go ahead and you can go to flat, medium, and steep cut slope and change these all from whatever they're set at default at. So the flat cut slope is going to be 2-to-1, and then you can change the medium slope to 2-to-1. You can change the steep to 2-to-1. You can leave them as they are, but sometimes the daylight will do some funky things if you do that. So we're going to do the same thing for the fill slopes. We're going to change those to 2-to-1, 2-to-1. Okay, and then the same thing on the other side. 2-to-1, 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 and 2-to-1. Okay, so now this cross section of our road is going to follow our horizontal and vertical alignments simultaneously. It's going to grade out this road with this crown, and then it's going to grade out this gutter, and then it's going to grade a flat, or well, 2% slope from the edge of the gutter for 8 feet, and then it is either going to cut or fill in order to tie into the existing grade at a 2-to-1 slope on either side. So this is now our assembly that we've created, and you can copy assemblies from one file to another. So we can grab this guy, we can Control-C, and then we can go back into our main file and paste. And now we have an assembly which has been copied over. And we're just going to go ahead and turn on this layer, the CA road assembly, which is what a lot of this is on. It's on the C road assembly layer. Okay, and now we've created our assembly. So like I said, you can do a ton of different things with assemblies. If we were to want to change the curb, we can simply swap out this sub-assembly for a vertical curb, or for an angle curb, or for any type of different curb, or even come into our sub-assembly and change the width of this curb if, you know, for whatever reason we have to do that. Same thing with our lane widths and slopes, same thing with our daylight slopes, and same thing for this flat area provided. We could switch this out for a sidewalk if we end up having to, you know, if we're required to have a sidewalk at some point, and it'll grade out a sidewalk for us, etc., etc. So you can build your sub-assemblies and your assemblies, or piece together your sub-assemblies to create an assembly to do essentially whatever you want it to do. And like we see in our corridor assemblies file, a lot of these are created with such detail that they'll grade out entire lots that are adjacent to the road. So the assembly will follow the center line of your horizontal and vertical alignments, which will be the center line of the road here, and then on each side to the left or right, it will you know, grade out certain lots. So you can essentially build your assemblies to do whatever you want them to do. However, the more complex you build your assembly, the more funky and weird your corridor will start to grade out certain parts of your site. So it's pretty important to build as simple of an assembly as possible while still meeting all of the design requirements.